This is the D flip-flop, which is a delay flip-flop, which provides the output same with respect to input, or whatever the input is there, that only it will going to provide at the output. So let's see first truth table of D flip-flop. Before going to form an excitation table, we have to see the truth table of the flip-flop. Truth table of the flip-flop. So there is a one input terminal, that is D, and one output terminal, Qn, and Qn plus 1, this one is next state output terminal. So first see the what are the inputs possibilities are there. The T flip-flop only have two types of input possibilities are there. That's only in terms of low and high. Low, it's nothing but 0, and high is nothing but 1. So Qn is nothing but present state, which means the previous output. So what are the previous output? We don't know what is the previous or present state present at the terminals. So we will consider that's like a undetermined signals. It may be a low, or it may be high. So based on that, the output will be available. So similarly, for high signal also, we don't know what is the present output present in the available at the terminals. So we will assume it's a predefined. It may be 0 or it may be a 1. So in a sequential circuits, the output will be available at both the combination of the input and present state. So according to that, the next state will be available. So we will think like that. If the D input is 0 and Qn present state is undetermined, then the output will also Qn, no change. Whatever the output present at the present state, that will only available. So it's an operation of D flip-flop. So if the 0 input is given, the 0 only available at the output. If high signal is given, the high will be available at the output. But according to present state, we will see what change will be happen in the excitation table. This is the basic operation of D flip-flop. So let's see the excitation table, how it will become. The excitation table is nothing but, here we know about the present state and next state. So for that state, what we provide the input. So we have taking Qn and Qn and Qn plus 1 we will consider here, and we are assuming what should be the input. So this is the difference between truth table and excitation table. In a truth table, what we are getting, we are predicting the output according to the input, what are the states are there. But in the excitation table, what it will be happen, there is a states previous, present and previous state. We should determine for that stage what should be the input. So that should be, we have to predict here in this table. So there are two combination will be occur. There are two inputs, the present state and present input. So there are this combination will be there, 0 0 0 1, 1, 0. So these are the combination because two inputs are there. So 2 inputs is nothing but 2 raised to the power of n combinations will be available there. So 1, 1. So these are the combinations. 0, 0, 0, 1, 1, 0, 1, 1. So if we have to predict what should be the input when the present state and present input, both present state and next state. So what should be the input? This is the present state, this is the next state. So for if present state is 0, 0 and next state is also 0, so what should be the output? We should provide at the input terminal. So we have to predict in this excitation table. So see here, if there are two terminals and 2 raised to the power of 2 combinations are there. There is nothing but 4 combinations are there. That is 0, 0, 0, 1, 1, 0 and 1, 1. So this is a present state. It's nothing but present state also called as a previous output. So this is present state. This is next state. If the present state is 0, if present state is 0, no signal, and it will converted into next state and it remains 0, then what should be the input? So we have to decide at what combination the input is there. So this is D. So the present state also 0, this state is also 0. So we have to consider it is 0, 0, 0 to 0. So it's nothing but this transition will become from 0 to 0 at what input? The D input is 0. Hence we have to provide the input 0 here. So at D is equal to 0, there is no change from present state to next state. Here, now come here. If the present state is 0 from changing from 0 to 1. So 0 to 1 is nothing but where the changing, this is changing 0 to 1. So what should be the input? Input is a D. So at this time we have to provide the input D here. Now here the state changing from 1 to 0. Here the changing from 1 to 0. 1 to 0 is changing at the what input? At the input D0. And the state 1 to 1, here 1 to 1 changing. This is the present state, this is next state. So there is a 1 to 1. It remains same at the what input when D is equal to 1. So this is the excitation table of delay flip-flop. This is the excitation table of delay flip-flop. So similarly, we also, so this state, the state diagram we have to also draw by using this excitation table. See here, there are a two state, one is a 0 and another is 1. There is a 0 and another one is 1. So how the state will be changed, we will see here. There is two state is there, one is 0 and another 1. And the state changing from 0 to 0. 0 to 0. The state is changing from 0 to 0. At what the input? At the input 0. If D is 0, the state remains same. The state changing from 0 to 1. This is state 0, this is state 1. The state is changing from 0 to 1. So at the what? The input? At the input 1. D is equal to 1. And the state also changing from 1 to 0. The 1 to 0 changing 1 to 0. And what the input? The input should be D. And the state changing from 1 to 1. It remains 1 to 1 and the input is 1. So this is the state diagram. We will see once again after all the excitation we have discussed, I mean, SR flip-flop and JK flip-flop, we have to see the how excitation table we will write on those only, and after that we will see how to make a K-map, and after that we will see again the state diagram. Okay. Now we have seen how the excitation table should be write for D flip-flop. So let's see for JK flip-flop. So before going to see how the excitation table will be write for JK flip-flop, first we have to write for SR flip-flop. So let's see the excitation table for SR flip-flop. So this is the SR flip-flop. First we have to see the truth table of SR flip-flop. Then based on that we have to write the excitation table also. So first write the truth table, then accordingly we have to write the excitation table also. So in a truth table, first we have to consider the input terminal. That is, there are SR table have two input terminal there. SR flip-flop having a two input terminal S and R, and two output terminal Q and Q bar. S and R. Then accordingly there are a output Q, and this is the present state output, and this is the next state output. So similarly in the excitation table also there are a, first we have to consider the present and next state. Here first we have to consider next present state, and then next state. After that we have to predict what should be the input. So this is the basic difference between excitation table and the flip-flop. Truth table. So let's see the possible combination of the input. There are two input terminal, and it's nothing but there are four combination of the input. That is 0, 0, 0, 1, 1, 0, and 1, 1. So presently we don't know what will be the present state. So we will make it as undetermined. But we know there may be a possible combinations. It may be a 0. It may be a 0 or maybe 1. Similarly, the value of this may be 0 or 1. See here, according to truth table, see if SR both are 0, 0. If we don't know what is the present state value, then the output will be Qn. It will be unchanged. But when the S is high, When there is S is high, the present state input is always low. Similarly, when S is sorry, when the S is low, the output is low. When the S is high, the output is high. If both are high, we don't know. This is a don't know condition. This is the disadvantage of this SR flip-flop. This can be eliminated by using JK flip-flop. So we will see in a later case. See, this is the truth table of the SR flip-flop. What will happen in the truth table? There are two input terminals, S and R. These are the possible combination of the inputs. And this is the present state and this is next state output. So presently we don't know what is the present state signal present at the terminal. So we don't know, but machine will be know, but we don't know. So we have to predict accordingly. So first we think about the both are 0, 0. S are 0, R are 0. That is nothing but this is a don't know. Then this is nothing but the next state will be unchanged. Whatever the data present or whatever the signal present at the present state that will remains at the next state. When the S is 0, R is 1, it's nothing but it won't bother about the QN. It simply set the next state to low. And similarly, when S is high, R is low, and it will don't bother about the signals present at the this present state. It will simply set to high. If both are high, it is a undetermined state. We cannot predict what is exactly the signals present at this next state. So hence it is called as a undetermined. So according to this, we have to establish the excitation table. So in the excitation table, first there are two output signals are there. That one is present state and this one is next state. So there are possible combinations of the signal is there because there are two terminals. There are a few combinational signal will be there. Those are only 4 because there are two input terminal. 2 into 2 is nothing but 4 states are there. That is 0, 0, 1, 1, 0 and 1, 1. These are the 4 possible combination of the output there. So in this excitable table, what we should do, we have to predict what should be the input to get this combination of the output in this present and next state. So if there are a 0, 0, it's nothing but the present state is also 0 and we have to keep the next state also 0. For that condition, what should we provide the input? So we have to predict. Similarly, if the present state is 0 and they are going to change the signal at the next state from low to high. So we have to keep that condition. So what should be input should be provided, we have to decide. So let's see one by one. First see. So first we have to see there are two combination maybe available at this present state, but we don't know. We have to think that there are a two combination. First one is 0 and second one is 1. And this is also 0, 1, 0, 1 and this one is we don't know. So if the state is going to change from 0 to 0, so we have to think about 0 to 0. If Qn is nothing but there may be a 2 signal is there, it may be a 0 or it may be a 1. If we assume the Q1 is 0, Hence, it will change from 0 to 0. So this yes, at what possible combination it will changing from 0 to 0, 0 to 0. So 0 to 0. So at what combination this signal we are getting? So this is also 0 to 0. There are two types. The 0 to 0 transaction will be takes place. This is one and this one too. So this one is takes place when S is 0 and R is 0. When S is 0 and R is 0. And this 0 to 0 transaction will be takes place when S is 0, S 0 and R is 1. So there is no other combination that transits from 0 to 0. So there are two possible combination. At this input, the data will be remains low from present state to next state. So this is not shifting. So it's definitely it's a 0. In both the case there are 0. But here the toggle will be takes place. Sometimes it may be 0. Sometimes it may be 1. So we are not considering this. We are considering this. So and we will think this one is a undetermined. So the output will be for that combination, the S should be 0 and this one is undetermined. R is undetermined. So for this possible combination. Now in another case, the state will be going to change from low to high. For low to high, at see where low to high will be takes place here. Low to high, it's going to takes place here. So there is only one combination. It will takes place from low to high transition. What combination is there? S equal to 1 and R equal to 0. So we can take directly S equal to 1, R is equal to 0. Then 1 to high transaction will be takes place. The Q1 to Q1 plus 1, 1 to high to low. So we will see high to low. Where is the high to low transaction will be taking place here? So high to low. So here, if the Q1 is this, we think if Q1 is high, then the output is here 0. The next state is 0. So there may be, this may be a combination of high to low. So at what input? 0 and 1. There is a one combination where the high to low will be going to takes place. So this is only one combination. So we can write directly 0 to 1. So S is 0. So S is 0 and so S is a 0 and R is 1. So at this time, if the present state we assume 1, there is a next state is 0 definitely. So for this transaction at this particular input, this transaction will be takes place here. Then see high to high. What will be the, this is one combination, high to high. And see another combination, high to high, this one. So S and R, here two combination will be takes place when both S is 0 and R 1, S is 0 and R is 1. Here 1 0. Here 1 0. Here the R is low in both the case, and here don't know. Sometimes it may be 1 0 and sometimes it may be 1. So how we can write it? We can write it like this. S is undetermined and R should be compulsory 0. So this is the excitation table for SR flip-flop. Similarly, we have to see what is the things going inside excitation table for JK flip-flop. So this is the JK flip-flop which is having two input J and K, and the another one is clock and Q output, Q and Q bar. Similarly, we have to write table for this only to make excitation table. First see the truth table. Truth table, and this one is excitation. table. Here to the table, first we have to consider about input. There are two input J and K we can mainly considering, and present state output and next state output. Similarly, in the excitation table, we have to take first the outputs, present state and next state. Then we have to predict what should be the output. So there may be a 0-0 combination, 0, 1, 1, 0, 1, 1. So this is don't know. So this is don't know. It's nothing but it is a 0 or it may be high. See, when J is 0, K is 0, if Qn is undetermined, then the output is only remains Qn only. Qn. It may be a 0 or it may be 1. So here, when J is 0, the what it may be the present state, the output should be 0, next state should be 0 there, and here if J is 1, the present state is definitely 1 is there. So in the SR flip-flop, when both the conditions are high, there may be an undetermined state is there. But here what will happen? The toggling will be happen. Toggling of this present state. So according to this, we have to write the excitation table. So there are also 4 combination. It may be high, zero, 0, 0, 1, 1, 0, and 1, 1. So there are 4 possible combination for present state and next state. So if such combination should be present in our this JK flip-flop, so what should be the input we have to provide? So with that we have to predict in this excitation table. So here first we have to see the state is changing from low to low, from present to next state is nothing but there are nothing changing. It's a 0 to 0. So we have to see the 0 to 0 combination is there. So there may be a 0 because this is a 0 to 0 and this one is 0 to 0. There are two possible combination, two possible states are there. On that the next state will be remain when the present state is 0. So These two combinations occurs when J is 0 and K is 0, and second one is J is 0 and K is 1. So it's changing from 0 to 0. First we have to consider from 0 to 0. This is one is J and this one is K. Here J, in both the condition J is 0 only and this K is toggling, hence we can say undetermined. So this is the J is 0 and K is undetermined. So we can predict like this. So next, the state changing from 0 to high. 0 to high, see the whatever the possible combination is there. This one is 0 to high. And this toggling is nothing but its present is 0, 1, and here we can say 1 and 0. Because it's a toggle of the present state. So we are predicting what 0 to high. So 0 to high combination, where is the 0 to high combination? This one. So 0 to high combination, at what stage of the input this combination will be occur? So first one is 0 to high when J is 1, K is 0. And second combination is both are 1, 1. J also 1 and K also 1. So 1, 1. So here J is high. In both the condition, K is toggling. So what is the possible combination is 1 and this is undetermined. So let's see the next state. The present state changing from high to low at the next state. So what are the possible combinations are there? High to low. This is the one which will changing from high to low. And second one is this combination high to low. So 0 and 1 at this combination we are getting high to low, and this one high to low. So here the K, this is the K and this is the J. At this combination we are getting this state transition. So here K is constant, K is high and J is undetermined. So this is J is undetermined. So next see high to high. So what possible combination we are getting like high to high? So this is at the 0, 0. At 0, 0 we are getting high to high and this one high to high. At 1, 0. So 1, 0. This 1, 0. Here the K should be 0. Here the K should be 0. And this is don't know. So this is the excitation table for JK flip-flop. So based on this characteristic, one equation will be determined there. The possible equation of this JK flip-flop, we will see. Like Q equal to Q bar into J plus Q into K bar. So based on this characteristic, this equation will be occur. So this equation will be considered in the operation for generating the excitation and state table for the problems. So this is the excitation table. We have seen how to write for delay, SR and this JK flip-flop. So let's see, the next topic is all about K-map. So what is the K-map? We will see in the next slide. The excitation table for the flip-flops plays an important role in the state machine design. With this table, with the table of this excitation, the signals necessary to produce the desired flip-flop output can be found. And the next step, the next state table is considered analyzing the state machines and also excitation table timing diagram for the flip-flops. But the by excitation table, the flip-flops inputs are derived, and then the K-map of the Boolean expression for the input signals are developed. The Boolean expression are implemented by using combinational logic circuit. The K-map is very helpful for uh, simplifying the Boolean expression. Here don't need to remember any Boolean theorem and anything all for this. So this is the most uh, flexible method for simplifying the expression, logical expressions. So let's see. We have seen the operation. There are some rules of the K-map. So before that, so this K-map shown in a figure, this is the 2 into 2 K-map. If there is a two possible combination is there, A and B. So there are 0 and 1 input terminal, and another one is two possible combination. There are four possible combination like this. So for example, if there are a two input or two variables, so 2 power of 2, 2 power of 2. So that's nothing but four possible states are there. So these four possible cells are written, and each possible cells are determined by the possible combination like a. So there are four is nothing but there are such possible combination like 0 0 0 1 1 0 and 1 1. So such type of possible combinations are occur here. So we can this bar is called as a variable separation bar. Hence here A is written here and B is written here. This 0 0. So this cell will be specify the these two variable relationship here, and 0 1. And this cell represents the these two relationship when this one is low and this one is high. And this cell represents the relationship between A and B when A is high and B is low, and this one is represents the relationship between variable A and B when both are high. So this is the 2 into 2 boolean, sorry, 2 into 2 K-map. And similarly there are 1 2, and there are also the this 2 into 2 into 3 is nothing but 8 possible cell. K-map is also there. See here, this is the variable separator. Here two variables are assigned, and this is one variable assigned here, 0 0 0 1 1 1 and 1 0. Why here the 1 0 is not appearing? This means that every cell which established the single bit change or single stage change here, 0 0 and 0 1. Here only one the bit is changing from 0 to 1. If there is a 1 0 combination will be occur, it means that there are two change will be there, 0 will become high and 1 become low. So it should be in a manner like a single change, single stage change. So like, so for that it represents like this. So there are a total 8 possible combination, and these assigns here the number they have given inside. These assigns the value of these cells. So 0 0 0 is nothing but 0 0 0 1 0 0 1 represents this cell 1, and 0 1 1 here like this. If there are such possible combination, there are three variable, so it which gives such time such type of combination 0 0 0 0 1 0 0 1 1 1 0 0 101 110 and 111. So this 0 means 0, and the value of this one is 1, this one is 2, this one is 3, this one is 4, this one is 5, 6, 7. Total 8 value will be represented there. So those value is assigned inside the number like 0 1 2 3 4 5 6 7. This 0 0 0 is nothing but this value is 0 0 0 1 0 0 is not 1. So 0 1 1 0 1 1 is nothing but the value is 3, and 0 1 0 0 1 0 0 1 0 is nothing but 2. So like that the values are named like this. So similarly there are 4 variables are there, a b c d. So for that 4 is nothing but 2 raised to the power of 4. So 2 raised to the power of 4. So there are total 16 possible combination will be occurs. So the 16 cells are organized in a K map. So here there are total 16 cells. So such type of combination will be occur. So there are several or there are few rules for grouping the K map. This map will be help for establishing the equation for the possible combinational uh, device, or the we can identify the equation and we can minimize the simplify the equations using this K map. We can do certain operation like this. So there are a few rules, so we have to keep it in mind. We have to assign the value if, for example, they have given the value a b c bar c bar and d. The y c bar d. So such type they have given for simplifying purpose. A, B, C, D. See, there are a 4 different variables are there. So we have to decide 4 into 4. K map can be a present set there. So, A bar, B bar, C bar, and D bar plus A bar, B bar, C, D plus A bar, B. So they have given equation like this. We have to simplify this. So we have to simplify. So first we have to convert. So here A is nothing but high, B is nothing but high. Here C bar is nothing but 0 and D is nothing but high. So we have to think like that. See, both all are high. Bar is nothing but 0, 0, 0, 0, 0, 0, 1, 1, 1, 0, 1, 0, 1. So we have to assign the high signal on this respective cell according to these values. See 0, 0, 1, 1. So 0, 0, 1, 1. So at this particular value, so the 0, 0 and 1, 1. So at this particular value, we should be assigned high, and 1, 1, 1, 1, 1, 1, 1, 1. So we have to assign high 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1. So 0, 0, 0, 0, 1, 1. It's already high. And 1, 0, 1, 0, 1, 0, 0, 1, 0, 1. So like this. So let's consider few another combination like a 0, 1, 0, 0. So means this is high. So what we have to make, there are certain rules. First rule is group may not contain 0. We have to group all these ones. We have to group with the neighboring cells. So we have to group. So the groups may not contain 0. The rest of the cell will contain say 0 here. If the rest cell will contain say 0. So the first rule is the group may not contain 0. Group may not contain 0. This is the first group, first rule. And second rule, we can group we can group the cells which will contain high. We can group one by high at respective cell, 2 respective cell, 4, 8, like this we can make a group. See here, there are 2 groups, so we can make a group with respective cells like this, and 4 from 2 group, 4 group. We cannot group it with a 0, we have to group with the high signal only. So the neighbor 1 where is there, we can group. So the maximum number of group, if we consider, then the signified value or the simplified value will be occur if the no one neighbor will be there, so we can individually group it. Each group should be as large as possible. So the group should be large as the possible. It's better to make a single group. We have to make a more number of groups. The more number of ones involved in a group, and the many number of groups is nothing but there are 1, 2, 4, 8. Wherever the neighbor this much number of ones will be present there, we can make it group. And another 4th rule, cells contain 1 must be grouped. So cells contain must high in a group. The group should be takes place for the value high only. The group cannot be made with the 0 values. So group may overlap. The group may overlap. Here we can make a group with the overlap. If 2 combination group have did, so there are another combination that will occur. So I can consider with this 2 like this. Or if I consider there is a high signal, so I can consider like this only. So I can make a many possible groups, and the group overlap can be occur. So next one is opposite grouping and corner grouping is also allowed here. Opposite grouping and corner grouping is allowed here. For example, if there is a high signal, is there, so we can make the corner group also. If there is high signal, we can make like this. So we can make like this, these 2 combination signals.